Hey, what's up, y'all? We are a little bit late, I know. That's because I've got this little girl. She is, say hi. Can you say hi? She is Little Pistol. She says hi. Hey, what's up, y'all? We are hold on just a second. Let me see if I can turn this down. There we are. But yeah, so we are going to ask or answer questions that you have over Pre-Cal 12 and AP Stats, and we're using this as a kind of study session. So come with questions, and we'll go through those accordingly, okay? And we'll rock and roll from there. So let's go to some of these questions over on this side. I'm going to do it in the order that they came to me in. So if you had a question, the quicker you put it in, the faster I'll get it done for you. And we'll go through those questions together. I've gotten a couple already. Okay. All right. We're going to do number 51 on your homework here. And this is AP Stats. So if you're looking at that, AP Stats is where we're at there. Okay. And she's not happy. She's not very happy there. But 51 refers to number 49, which says that we're talking about songs on an iPod, which who has an iPod nowadays? Says that it has about 10,000 songs. The distribution of the play times for these songs is heavily skewed right. So out of these 10,000, you could think of 10,000 as my big N here, okay? That's skewed. The mean of this, though, the mu of this is 225 seconds. And the standard deviation of this would be 60 seconds, okay? Now, the question on number 51 asks, how many songs would you need to sample? So this is population up here, right? So when it talks about how many songs I need to sample, if you wanted the standard deviation of the sampling distribution. So we're going to move from there to more of a sampling distribution. And because we're talking about the mean length of the song, we're going to focus on the mean instead of the proportion. So if you got your chart where it divides it up into two, that would be a really good idea to kind of pull out here. We've done the proportion, and the mean now, which is the right side of the column, is what we're focused on. So the question with number 51 asks, how many songs would you need to sample if you wanted the standard deviation of the sampling distribution of X bar? So we want the sampling distribution, standard deviation of X bar, to be equal to 30 seconds. We want this to be 30 seconds. So the question is how many little n's, or how many do we need to sample in order to get to this value up here? So the first thing I like to do is, with the yellow is everything that's been given, let's put down standard deviation of X bar is equal to the, sorry about that, put down the wrong formula. It is the standard deviation over the square root of n. Okay, that is from your formula, that right side of that formula sheet that's there. So this is from my population, so that's 60 seconds. Okay, and the square root of n is what I'm looking for. We know that 30 seconds is what gets plugged in here, so we're going to set it up as 30 equals 60 over the square root of n. So we're going to solve for n by multiplying by the square root of n on both sides, to where 30 root n equals 60. We're going to divide by 30 to where now the square root of n is equal to 2. So we're going to multiply this by squaring both sides there. And when I do that, my n will be equal to the value of 4. So if I'm looking for my standard deviation to be 30 seconds, I would want to have a sample size of 4. So how many samples I would take would be 4 there. Okay. All right. Very good question. Y'all have any other questions? Throw them out there. I'm going to look at my email. I'm going to look at my text messages. So if you've got it, throw them out there. Continue to come in with that there. All right. Yeah, this is really good. So on this one, Jada comes in with number 8. see here, 8 on 2.1b. So we're going to hop back and forth. This is pre-cal 12. So if you see an AP Stats, if you're in AP Stats, you kind of tune me out or kind of have the next question ready on that. So just a heads up on that part there. Yeah, great question. Number 8 is one that it's not as big of a deal if you know or don't know, to be honest. It's not the end of the world either way. So let me do this. Let me say this right here in the chat. You can also put this in the chat. So just saying, put questions there if you want to. What I probably will do, I might give some like extra points here if you like do this one. We could kind of start this process off here and then move forward. But this says solve for the real world problem to the bottom right of this page. It says determine the radius of the semicircle. Okay, so first off, an indoor physical fitness room consists of a rectangular region with the semicircle on each end. The perimeter of the room is to be a rectangular region with a semicircle. The perimeter of the room is to be 200 meters single lane running track. Okay, so we've got this here. So it says okay, consists of a rectangular region with a semicircle. The perimeter of the room is to be 200 meters single lane running track. So it says determine the radius of the semicircle ends of the room. So what I see, and here's what I'd like to kind of look at here. I want to look and see how I interpreted this when I did it there. But we want to look and see first off if we can determine the distance in terms of y around the inside edge of the two semicircle parts of the track. And so that's what we're looking for here. Might be easier if I pull this up. Let me see if I can pull this up here. Let's see if I've got this one here. Yeah, perfect. Okay, might actually pull this one up. Yeah, but what I was trying to do is trying to see if okay, yeah. So the perimeter of this, so it's 200 meters single lane track. Okay, that's what I was looking at, the wording there. So we're saying that the perimeter of this is 200. So P is equal to 200 meters. So how do I find that? Well, I could say first off, the perimeter is what's on the outside. So I have an X and an X. So I could say that the P, instead of putting P here, I could say 2X plus, and how do I have two semicircles? Well, the perimeter of this semicircle here is 2 pi r divided by 2. And the radius, we don't know, but we do know that if y is the diameter, half of this would be the radius, so that would be like y over 2. So we're going to put y over 2 in for r, okay? Now, the kicker with this, so we're going to put 2 pi over 2 times y over 2. And because there's two of these, one, and I don't want to confuse you here, one on the outside and one on this side, we can say that there's actually two of them, so we're going to multiply this by 2. Now, this is kind of a little weird, isn't it? It's kind of a little strange. Equals then 200 meters. So if I were to simplify this, these 2's would cancel. This would also cancel, simplifying to 2x plus pi y equals 200 meters. So the question is to determine the distance in terms of y around the inside edge of the two semicircle parts of the track. Okay, determine the distance in terms of y around the inside edge of the two okay, so let me make sure. Determine the radius of the semicircle ends of the room. Determine the radius. Okay, so the radius of the semicircle ends of the room, okay, right here would be y over 2, right? We talked about that. We can't really solve for it at this point. We're just putting it in terms of y. Now it says determine the distance in terms of y around the inside edge of the two semicircle parts of the track. So the semicircle edges would be here and here. So that perimeter would, we already kind of solved for it, would be this. So if we canceled it, would be pi y over 2. Okay. So we've done those two parts. We've kind of just gone ahead and done, kind of went ahead of what we're looking for. B says use the result of part A to write an equation in terms of x and y for the distance traveled in one lap around the track. Okay, we've done that. And now it says solve for y. So to solve for y, we subtract 2x on both sides. Okay, so we've got pi y equals 200 minus 2x. And then I can simply divide by pi to say y is equal to 200 minus 2x over pi. It's a little strange with what we're looking for here. I know it's a little bit weird, but we could just basically keep that and roll with it there, okay? And rock and roll. So we're looking for this value in terms of y. Does it say solve for? Oh, then it says solve for y. I'm trying to see if they gave us anything else that's there. Gotcha. I don't see anything in terms of y. Use the result of part to write an equation in terms of x and y for the distance traveled in one lap around the track. Then it says solve for y. I'm trying to see how there's a way we could have solved for the area, and that's what I was looking at there. Tell you what, in this example, I don't think it gives us the area. Perimeter of the room is to be a 200-meter single lane running track. I don't see the area. I could be missing this, but we could just leave this as is, solving for terms of y here, and be okay with that there. Okay, at this point. So yeah, I'm good with that. Unless I could have read this a little bit off. If you just kind of follow this is not going to be on the test. And that's what I was looking at is the logistics there. But what we'll do is we'll leave this as is because it will not be on the test and it won't be on the quiz. It's just kind of a little bit deeper thinking that's there. Okay, Jada, thank you for putting that though. That's a really good question. And one that I appreciate you for asking. Really do. All right. Any other questions that are out there? I did get quite a few. Questions in regards to, like, hey, coach, I'm not really understanding some of this stuff. Have some questions on one thing or another. So now would be the perfect time to ask those questions. So come on. And I'll just kind of wait and got questions, throw them out there. As I looked at this too, I want to see if I can. I think actually, as I look at this, Jada, if you're still there, I think I might have messed up on this because this right here, when I think I put two twos here. I was thinking about that just as I was looking at it. As this cancels, this would be like 2 pi y. I think it would be here. And then this would actually be divided by 2 pi once I had it here. I think I had too many 2's here. So this should be here to where when I divided, I could actually divide all 3 of these by 2. So the actual correct answer, that's my fault, should be 100 minus x over pi. And again, as I was thinking, I think I put one too many 2's on that, which kind of threw that off there. But if you can kind of get this in terms of y, right now I am good to go. Okay, good to go. All right. Does anyone else have any other questions? Anything else that's out there that we can address? Come on and ask those questions there. And we'll rock and roll. So I'll kind of wait and see if you have any other questions. Come on. All right, just waiting, holding on tight. Right now, I know I've got a viewer out there. If you have any other additional questions, come on, throw them out there, and I'll go from there. So keep asking me. Also, just a heads up, as I'm looking at some of my solutions that I've done, if you are looking and seeing like, oh, coach, I'm still kind of confused on that one. Again, not one that I really want you to be stressed about, but if you do still have a question about it, I'll throw this up here. This is the solution right here for the area. So it kind of goes on to say solve for y basically. And you'll notice that if I did x times y equals a, I used the expression that I had left over. And what I did was substitute this in for x. And then I multiplied by y here. So y times this. Once I distributed it, I got 100y minus pi over 2y squared. Once I distributed the y to both of these sides. And basically what I would do then is solve for, seeing here. Basically, then I would solve for y to where if I set this equal to 0, I could kind of figure out what y would be here. So if I set this value equal to 0, like I would solve a quadratic, I could solve and figure out that 31.85 would be my solution. Again, not a stressor, but is one that just in case you wanted to know or try to go through, we could do that together. At this time, I know that, yes, 7. Let's do it. I just got another one here. Thank you, Jada, for providing that question there. Number 7's one that's a good one. This is, again, section 2.1b. As you look at that there, big one for what we're looking for on the quiz and a big one for the homework as well. Okay, so let's look at this here. 2.1. Okay. Number 7. Okay, so number 7. Ooh, actually, there's 2 number 8s. I noticed that. If I did the wrong number 8, let me know. I could probably do both of them. The one on number 7 is when we have 2 zeros of 4 and 8. So if I were to be given 2 zeros at 4, 0 and 8, 0, this is actually also on section 2.2 as well. How can I get this to where I put it in factored form? Well, if I have a 0 of 4, I can say that the factor of this would be the opposite, which is x minus 4. And with 8, I can say that it's opposite, and that would be x minus 8. So really, it's kind of going backwards from what you think traditionally of having the polynomial, and then from there being able to say, okay, x minus 4 and x minus 8 are the 2 factors. Then at this point, if I set it equal to y or f of x, let's distribute and find that in standard form. So I would then say, okay, x times x is x squared. X times negative 8 is negative x. Let's do the 4s now. 4 times x is negative 4x because it was negative. And negative 4 times negative 8 is negative 32. Okay? Now combine like terms to get x squared minus 12x minus 32 equals y. And that right there is the positive quadratic that goes through the values or the zeros of 4 and 8. So if it went through, it would be like at 4, 0 and 8, 0. Now, the question is can you find a quadratic that does the same thing, except now goes through the both zeros again, except this time we're going to say that it goes downward. Well, the only way that you need to switch this is to do the same exact thing except provide a negative to it. So now we have negative x squared plus 12x plus 32. That would still produce the same zeros. The only difference now is it would be the one in yellow compared with the one in blue. So again, just a heads up with what we're doing on that one. That's again number 7. I think there is another number 8, which is a little bit more of what we would be looking for, where it says the sum of the first and twice the second is 24. So first of all, it says there's 2 positive real zeros, one x and one y, where the product is a maximum. So we're going to hold on to that. The second statement on the first number 8 says the sum of the first and twice the second. So the first and twice the second is or is equal to 24. Okay. So again, x times y equals maximum. X plus 2y equals 24 is what we have. So now what we want to do is we want to plug this value or this expression in for the top equation. Okay. So we would say in this example, x is equal to 24 minus 2y, because I'd subtract 2y to both sides here. And there you are. So now I'm going to plug this in for x to where now we have 24 minus 2y is what goes in for x. Multiplied by y, it produces what my maximum is. So I'm going to multiply y across to make 24y minus 2y squared equals my maximum. And remember that this right here, if I put it in order, I'd probably put it in as negative 2y squared plus 24y equals my max. So how do I find this vertex? Well, you can imagine a picture right now. The picture is going to go downward, right? So we're trying to find what is the maximum of this expression, of this quadratic. So we can find the maximum by finding the vertex. But this time it's a little weird. To find the vertex, it's in standard form. So we can either plug this in my calculator or I could do negative b over 2a. So the b would be 24. The a would be negative 2. Negative 24 divided by negative 4 would be positive 6. And to find what the other value is, we can plug that in and plug 6 back in. And this is a little different because right now this expression would be, again, a little weird because this is the y squared here. So we just found what the y was, if that makes sense. To find what the x is, we would say, okay, plug 6 back in. We'd say -2 times 6 squared, which is 36, plus 24 times 6. And we could find that by plugging it in and getting whatever the value is out. So we would say -72 plus 144, subtract to get 72. And so I got 72 for x and 6 for y. Did I do that right? I don't know. That doesn't sound right. Let's see here. Plug 6 in, get 36 minus 2 is 72. Work here the 2, 144, positive 72 is what I got here. Here's one thing. I want to try to check something here on this one. In fact, I'm going to do this before I do. I think I might have messed up in terms of, because I solved for y. We actually wanted in terms of x, which would be a minor tweak there. Let me just check and see this real quick. Looking and seeing. Yeah, so what I should have done, or what should have happened, is x is equal to, if I did this part right, let's go back here. Let's see here. Yeah, so when we did the vertex here, actually, yeah, so in doing the vertex, what we can do is this value, did we get y is x and 6? X is 6, y is 72. X is 6, y is 72. Yeah, actually, okay, so we're good to go. We're good to go there. I think the big thing here was, okay, x is this equal to this, and y would be more like, again, 72. What I probably should have done, and I'll do this in white, is probably solve for y on this. Probably be a little bit easier. That way when I plug in, you kind of see it and go from there. But again, the vertex would still be this expression here. So just again, a heads up on that when you're doing it, when you're plugging in. But yeah, that should be good to go. Should be good to go there, and rock and rolling. So if you got any questions, let me know. We'll continue to go through it, and we'll go from there. Okay. Does anyone else have any other questions at all? I know I did an additional one right there, Jada. My apology for that there. All right. If you got any other questions, come on, throw them out there. Throw them out there. As I'm waiting here, again, this is just really for me. If you want to hold on and continue to watch this, that's fine. I'm just waiting for questions. So if you have any additional questions, come on. I might do another one off 2.1b here in a second. I'm looking and seeing, could I solve for y here? So let's say 2y is equal to 24 minus x. It's a little different than over here. If I divided by 2 here and here, I would have y is equal to 12 minus x over 2, and I could plug it in up top. So it would be x times 12 minus x over 2. And if I distributed this, this would end up equaling, and again, this equals my max, right? Just, again, I'm plugging in something different. 12x minus x squared over 2, and that equals my maximum, okay? So again, if I were to rearrange this, negative x squared over 2, or negative 1/2 x squared plus 12x equals my maximum. To find my vertex, I do negative b over 2a. b is 12, so negative 12 over 2 times negative 1/2. That's there. So 2 times negative 2. Okay, perfect. Cancel, cancel. That'd be negative 12 over negative 1, which is 12. Actually, this might produce just a little bit of actually, it would be a different answer here because we have to get it to where it's y equals x. X has to be inside. And that was my fault here because I produced it as if it was y. Y was a part of it. So now 12 is the x. To find the y, we plug 12 back in. 144, negative 144 divided by 2 is negative 72. Plus 12 times 12 plus 144. So negative 72 plus 144 is 72. I got 72 and 12, but hold up, I want to make sure of that. Is that right? 72 is good here. I'm looking and seeing the y stayed the same. The x was a little bit different. So that's what I'm looking for here. So yeah, I would actually take this bottom one here. On this one, that's the one I would be focusing in on if that's again something that that you're doing there. So yeah, so that one right there, I would be sure to put x in terms of x, and I think that would be much better because that again, when you think of a quadratic, it's y equals x squared, right? So once I get it into this format, I can do the negative b over 2 times my a, which is negative 1/2, and then I could rock and roll from there. So that's how I would approach it on this one. All right. All righty. Any other questions? Does anyone have any other questions? We can do another one off of 2.1b. Could also do that one as well. I'm trying to see another one. Let's do number 5. How about that? The vertex being 2, 3, point is 0, 2. It's 2, 3. Point is 0, 2. Making sure here, 0, 2. Okay. All right, so with vertex form is y equals a parentheses x minus h squared plus k, to where h is 2 and k is 3. So let's plug it in to where we have y is equal to a parentheses x minus 2 squared plus 3 on the outside, okay? Now, in order to, because of the fact that this is vertex form, the vertex associates with h and k, okay? So we know we're good to go there, and we plug them in, but now we've got to solve for what a is. And we do that by plugging in x, and we plug in y of 0, 2. So we would say then y is equal to a parentheses 0 minus 2 squared plus 3, and also the y would be now 2, because again, we're plugging in the point of 0, 2, or x and y in to solve for what a is. So really, we're looking for this equation, except now we're focusing on what is the value of a. So in order to do this, we say 2 is equal to a times negative 2 squared plus 3. So PEMDAS, good old PEMDAS tells me negative 2 squared is 4a plus 3. So 2 is equal to 4a plus 3. Subtract 3, negative 1 equals 4a. I then divide by 4 to where a is equal to now negative 1/4. So simply I just take negative 1/4, substitute it back in for my original to where now y is equal to negative 1/4 parenthesis x minus 2 squared plus 3 on the outside. Okay. And again, that would be the equation in vertex form. Okay. Great. See any other. I've got one viewer out there. I think that's probably me because I'm watching it right now. or at least staying up to date with it. If you're wondering if there's a game tonight, there is no game tonight. So just a heads up there. We're good to go. All right, let's see here. Any other questions on my email? Gotcha here. All right. Let's see any other questions there. If you have any additional questions, contact me tonight or even tomorrow morning, and we'll be able to go through that together there. That, okay. I'm trying to see. So I'm going to throw out, I'm going to do this pre-cal 12. I'm going to send out a Remind 101. Kind of hold up right here. Again, I'm just here. Questions, you could throw those out there. Yeah, Jade, I appreciate you for being here. Let's look at homework section 2.2, number 5. Yeah, let's do it. Negative x squared plus 10x. Okay. I think I've got that on this one. Let me see if I've, yeah, sure do. Number 5 is down there. Let's check this one out. Very good one for the quiz. Very, very good one. Okay. Let's start with part A. Part A says apply the lead coefficient test. Well, the lead coefficient test focuses on 2 things. Number 1, what is the lead coefficient? Okay. And number 2, what is my degree? Now, the degree refers to my highest exponent. And in this example, the highest exponent would be 2. Okay, so the degree would be 2. As far as the lead coefficient goes, the lead coefficient is the value or number that's in front of x squared. Well, that lead coefficient or that number that's in front of x squared would be a -1. Or really all we need is the fact that it is a negative value. So the question becomes, knowing that the lead coefficient is negative with the degree being 2, what is the end behavior? Well, the end behavior, I've done it 2 different ways. I like to just say, what happens the furthest left? What happens the furthest right? Is it rising or is it falling? So we look and see that, we remember that a lead coefficient, when it is positive, both will rise or both will fall, right and left. But if it's negative, they do opposite. We either rise right, fall left, or rise left, fall right. We can go back and we'll need to know this for the test, but for the quiz, you can kind of have this here. when the lead coefficient's negative and the degree is odd, we see that we fall to the right. You see the picture here. We don't know what's happening in the middle, but we know we rise to the left and fall right. So we'd say this here. We go, okay, we are going to rise to the left. We don't know what happens in the middle, and we fall right. So we say rise left and fall right. Okay. Another way we can say this too is as x goes to negative infinity, as we go to the left here, f of x is going upward, so f of x is going to positive infinity. And as x goes to positive infinity to the right, f of x is going to down, okay, is negative infinity. Think of f of x as our y, okay? Now the next question is find the zeros of our polynomial. So I'll do this in orange. This will be part B. We know that in finding the zeros, we are going to plug 0 in for y. So 0 equals negative x squared plus 10x minus 16. And because this is negative, we can assume that the graph is going to be going downward, making our vertex a maximum. So just a heads up there. But for factoring, it kind of can be a nuisance. So we're going to take that negative out, leaving us with x squared minus 10x plus 16. Okay, so we take that negative out, changing the sign. It makes it much easier to factor the inside when x squared is positive. So we say, are there two values that when multiplied get me 16, but when added get me negative 10? Well, the values that make up 16 are 1 and 16, 2 and 8, 3, 4, and 4. And I think that's it. So we can say what 2, and all the negatives of that 2 could multiply to positive 16. What 2 when added get me negative 10? Well, that would be x minus 2 and x minus 8. So when we factor this now, and if we couldn't factor it, we would use the quadratic formula, but you can clearly see we can. We set both of these expressions equal to 0. So we would say, okay, x minus 2 equals 0, x minus 8 equals 0, add 2, add 8, x is equal to 2, and x is equal to 8 in terms of the zeros of this polynomial, okay? It then goes on to say, plot the sufficient solution points, draw a continuous curve through these points. So we know that we are going to, oh man, actually messed this up because I saw this degree as odd. It's actually even, right? And so if I went back here, this was my fault here. I was looking at the 1 over from it. When it's negative with a degree that's even, this should both fall to the right and also fall, sorry about that, fall to the left. So as x goes to negative infinity, f of x will also go to negative infinity. The reason why is I looked at this 2, and in my head I saw it as a 3. So the degree is positive 2. That's why we'd fall left and fall right, which should make sense because a quadratic would either both be down or both be up there. Okay. So now the question is how can we graph this? So kind of backing up here, kind of erase all this, and it doesn't say use a calculator, so we got to be careful of that. We know we're going to have 2 that are going to fall left and fall right. We know the zeros are at 2 and 8. Since the zeros are only repeated once, we know we're going to go through that, right? So we're going to go through it and fall to the left and fall to the right. To help us out a little bit, we can find my y-intercept. So let's find my y-intercept, and I can do that by plugging 0 in for x. So we'd say 0 squared plus 10 times 0 is 0 minus 16. So my y-intercept would actually be negative 16. So 0, negative 16. So we're just going to say that this point down here is at 0, negative 16 when I graph it. If you have more room, you could actually do 16 tick marks downward, okay? So that's what we're looking at there. So we're trying to see now what is the axis of, well, symmetry, but then also what is the vertex here. To find the vertex, we can kind of solve that by doing 2 methods. You can kind of count between, because we know as we look at the x-intercepts, a lot of times the graph will be kind of in between, but we're not 100% sure there. So we can do our vertex form by saying, okay, let's plug in in the negative x squared plus 10x minus 16, let's do negative b over 2a. B would be 10. A would be negative 1. And negative 10 divided by negative 1 would be positive 5 there. To find the y of this, we plug 5 back in. So we would say negative, parenthesis, that's important, okay? The negative will not go with the 5 because we have to square it first, then have the negative, right? Because that's what PEMDAS says for us to do that. And so 5 squared is 25. So we have negative 25 plus 50 minus 16. So 25 minus 16 is equal to 9. So 5, 9, 1, 2, 3, 4, 5. And we'll go all the way up to 9. This graph right here at 5, 9 would produce our quadratic. So 5, 9 would be the vertex. And the axis of symmetry, you don't need to know that, but the axis of symmetry would be at x equals 5. Notice it's not very symmetric. To kind of be a little bit more symmetric, we would probably draw this a little bit more. Let's see here, probably a little bit more. Let's go right here. So where it's a little bit more spread out and more even to where, again, the axis of symmetry should divide on top of itself there, okay? I think there should be one more tick mark here, the way that I counted 1, 2, 3, 4. So it should actually be like right here. But you get the idea. That's kind of how we would do it there. Okay. Awesome. Any other questions? Y'all, any other questions? That was a long one, I know, but I wanted to make sure I at least address those questions that were there. Any other questions that y'all have for me? Continue to throw them at me. I've got about 10 more minutes, so I'm looking at my emails, I'm looking at my chats, looking at my phone. So keep letting me know. And just so everyone knows, I know I did a question on 2.2a. Remember as well that is not a requirement for y'all in terms of doing that for tonight at midnight. The homeworks that are due are 2.1a, which should have been done yesterday, and 2.1b, which should be done tonight. 2.2a is kind of where we're headed for tomorrow. So just kind of keep that in the back of your mind when you're studying. Also, yeah, so I would just say just be leery of that going forward. If you get done tomorrow and you need something else to do, the extra problems that are right here are ones that I would be very tuned into when doing them in preparation for the quiz. So if you need some help or additional practice, this would be a great place to start in class tomorrow as you go through that there. Okay, just a heads up on that. All right, I'm just going to kind of hang loose here for a couple minutes. If you've got any additional questions, feel free to continue to pull that up. and we'll rock and roll. And if you have any other questions, let me know. All right, I don't see any other ones that are there, so we're going to close shop today, and I hope you have a fantastic day. We'll go over some questions later on. Tomorrow morning, I will have a help session, so come in if you need to, and have a fantastic day. See y'all. Bye.